Welcome, Aditya.
Thank you.
He will speak about web storage.
Hello, am I audible? Someone respond, am I audible? Hello, am I audible?
No, I'm not, I guess. I am on. I can hear myself. Oh, this is amazing technology. Hello, everyone. I'm Aditya, and I wasn't supposed to give a talk today, but one of the speakers had to bail out. So I thought, why not just give a small talk on web storage, the most exciting thing on the internet. How many of you here build web applications? Write JavaScript? Come on, everyone. Yeah. Use Backbone, jQuery. Yeah, so you guys do all this stuff quite frequently, so I'm guessing this won't be much unfamiliar to you. So what exactly is web storage? So there are two kinds of pages on the internet. One is web pages. You just go to a URL, you see content, you click on it, and you go to another page with another content on it, and this goes on. But then there are web applications like Gmail, Yahoo Mail, Dropbox's interface, where there's Ajax involved, and there's a lot more technology involved on the UI side. But the problem with these interfaces is that they don't really work when you're offline. They don't really store anything locally for you. The concept of web storage is that we have a lot of APIs available on the browsers today that we can use to store that data locally and improve the performance of these applications. So if you use Google Mail offline, which is available on Chrome Web Store, it uses WebSQL. And even if you're not online, you can still access your mails. There is a console for Dropbox available on Google Chrome Store, which doesn't download all your files, but downloads all the list of files. So you can see what files are available to you. Similarly, if you're building an application that uses Backbone and you want to make it available offline, or just want to make it highly performant, you have to use one of the possible APIs that web storage gives you. And web storage is not an API, it's a vague term that covers a bunch of APIs that go all the way back to the 90s. How many of you are familiar with the concept of cookies? Well, people have used cookies for storage. You shouldn't, but people still did. Essentially, cookies are meant for transport between server and client, but people use it for storage. But they are not the only things people use for storage. So I'm going to list down all the things that people did use for storage. Cookies, yay. How many of you know window.name? Let me explain what window.name is. This is the most amazing hack of all time. And it's consistent across all the possible browsers that you know of. It's a hack that works across all damn browsers back to IE5. DOM doesn't work across all the browsers, but this hack works. What it does is, if you say window.name equal to some string, which can be as long as 3 MB, you go out and you come back, it's still there. So if you want to store some information related to a client, just store it in window.name. You don't have to set it in a cookie and transport it every time.
What's that meant for?
It was meant to, basically, if you have multiple frames, they can recognize each other via their names. So when you store anything on window.name, it persists. Also, since it was meant for basically recognizing each other on frames, you can also use it for communication. So if you set a property of window.name on one frame, other frames can read it. So you can use it for cross-frame communication, which is not available in any of the old browsers. You have basically message passing now on the new browsers, but old browsers didn't have it. This is the best hack of all times. Web storage, communication, whatever, just if you like hacks, have a look at window.name. Well, things started evolving. People said, oh, we don't want to send all our client data on cookies. We want to identify client's information and just keep it on the browser. And when he comes back, we want to see that again. So that's where local storage came in. And IE8 was one of the first browsers that implemented it on Windows, I think. Anyways, so local storage is essentially a key value store where you say my key equal to my value, something similar to what we do in cookies without all the expiration and HTTPS and domain and all that crap. So you just store something, and when you come back, you have the data still available. it worked pretty great, but then people started abusing it, storing shitloads of data on it. Let me tell you something really awesome about local storage. It looks like a key value store. It's a flat file in the file system. So every time you write something, it modifies that file, saves it again. Every time you have to read, it reads the entire file. Well, that's a high-performance thing, is it? Well, even if it's not high-performance, even if it's CPU-intensive, another problem with it is that it's synchronous. When you say local storage.get item X, and if this X is 5 MB long, your entire browser freezes because it's reading the file, parsing it, and then giving it to you. So, okay. Session storage was something similar. I don't think I need to go into the details of session storage in Google Gate. We'll just skip that because the last three are the most important ones here. People saw that local storage wasn't cutting it. They needed asynchronous storage API. So that's where WebSQL IndexedDB came in. I'll first talk about the storage aspects of it. Then I'll talk about why and when do we use these. So WebSQL is essentially a SQL-based engine in your browser. I'm guessing everyone here has worked with MySQL. Hands please. Anyone? A lot of people. So you know how SQL works. You create tables, you dump data into it, insert, upsert, delete, query, whatever. Well, WebSQL is pretty much the same. It just uses SQLite on the browsers. So you create tables, you dump data into it. When the user comes back, you read back data from it. And the best thing about it was asynchronous. So if you have lots of data, it runs in a background thread. When the data is ready, you get a callback and you get the data. So the UI doesn't freeze. If you're loading your 50,000 emails, it can all happen in the background. So this was a major advancement. But unfortunately, SQLite is not a standard. And Firefox and Microsoft and Opera and Apple and pretty much anyone who makes a browser just disagreed to make a SQLite standard. No one was just ready to make a SQLite standard because everyone has their own idea of what SQLite should be like. So everyone implemented their own SQLite engines, and they were always inconsistent. And they deprecated that SQL because everyone was just fighting. It just never happened. Well, somehow someone said, well, there's no WebSQL, if there's no local storage, we need something. We need one good data storage engine in the browser. W3C said, oh, we make a better one. We make an object store in the browser. Let's call it IndexedDB. Great idea. You can store objects without serializing. If you're talking about WebSQL local storage, you cannot dump your objects as it is. Your objects have to be serialized to a string and then stored. But in IndexedDB, you can just say, take my object, store it, and the objects get stored as in. And if it has fields on it that you want to be indexed, just like MongoDB, they get indexed, and you can query on those indexes. A brilliant idea that W3C royally fucked up. It's unbelievable how bad the spec is. It's unbelievable how bad the implementations are. Yeah, let's go ahead. I gave you the options. Now, file system API is essentially a upcoming spec of way of storing files locally on a client in a secure way that nobody else can read it, but when you come back, you can read the files back. So if you don't like WebSQL IndexedDB, you can implement your own storage engine and dump the files in the file system API if you want. Yeah, I like to say that. Screw you W3C. How many of you think the DOM is a crappy API? Come on. Oh, I guess a lot of you use jQuery, I guess. How many of you did use DOM like before jQuery came in? And you don't remember the pains of it? Okay. Cookies, yay. So cookies is not a storage option. People use it a lot. We said document of cookie is equal to my key equal to my value, but honestly, please don't do it. It's not a great option. It's not. Because every time you set up cookie, it gets sent on every single request to the server. You are downloading an image, and all that 2 KB of data that you stored in the cookie gets sent unnecessarily for the image request. Something you don't want. We're talking about making our internet as fast as possible. That 2 KB on every request is a lot of data. It doesn't sound a lot, but it becomes eventually when you add it all together. Don't use cookies if you don't intend the data to be sent to the server. Actually, I would suggest don't use cookies at all. If you're using Ajax, just send all the data in post request. Window.name, yeah. Any questions on window.name? I'll probably like this session to be more interactive. Questions? as we go. Window.name questions? You can say window.name equal to JSON.stringify object.
What is the storage limit for
Okay. His question was, can you use window.name to store objects? You just say window.name equal to JSON.stringify object. That just converts those objects to a string and can store it. And when you're loading the page, you can say window.onload equal to function, JSON.parse, window.name. You have it. Yeah.
How about the limit?
So some browsers it's unlimited, but the common highest denominator is 3 MB. That's a lot of data. Okay. Yep. Mike. What? How secure? It's not at all secure. That's the thing. It was not meant to be used as storage. It's a hack. The purpose of window.name was for frames to identify each other with names. And you don't really want to implement security when people are communicating. You want them to know each other's names. So it's also used for communication. So if you have two frames and they want to talk to each other, you just set name on one of them, and you can have a parent window running a set timer or set interval that sees if the name changes and tells this name to the other person. Or the other iframe can also run a timer and read the name. So it's also used for communication across frames. Post message is a very new API that's still not implemented in all the browsers. It's in the modern browsers, but not available in the browsers in use. Then DOM storage, I mentioned local storage, uses a file, saves to file every time you write something. You write a lot, saves a lot, freezes a UI, you get pissed. Forget it, don't use it. Don't use it, please. Listen. Again, web SQL, wrapped up. What the hell? Sorry. Yeah. The web SQL is deprecated, but it's still a great solution because IndexedDB is not available across all the browsers. But if you take a combination of web SQL and IndexedDB, somehow you can write a system that talks to both of them. You can address 98% of the browsers available on the internet today. So if you're building an application that needs to store data, even if you may not be offline, just for performance, you might download like 10 MB of data every time it goes online. You can store that data and then just read it back and not request for all data every time. So web SQL is available in Opera where IndexedDB is not available. It's available in Safari where IndexedDB is not available. It's available in older versions of Chrome. It's available on the Android browser, which amazingly is really crappy. It's the i6 stuff today. It's available on iPhone. So if you have any storage needs, IndexedDB is a great solution, but it's not available everywhere. So you have to look to web SQL eventually if you're building a production app. And then of course we have IndexedDB, which is of course the latest fuck up by W3C. I have another slide on why IndexedDB is a fuck up, but I'll see if I can pick it up later. So this session was essentially supposed to be Q&A, but I'll probably give you an idea of why we need these APIs, why we need web SQL, IndexedDB, local storage, cookies, window name, any of these things. You might not be building an offline Gmail. You might not be building anything offline, but you can still use these tools to improve the performance of your app. How many of you have written a web app that uses Backbone? Or at least work with Backbone? And you know when you say you have a model and you say model.save or model.sync, or you can say collection.fetch, it makes an AJAX request, right? And to a REST API, let's say you build a Twitter client and you want to download all your Twitter data. Do you really want to download all of it every single time? Why not just store it every time you get the data and just request for the next changes? So you can download the data and store it in any of these APIs. You can store it in web SQL if you want. If you can store it in IndexedDB, it will be indexed. You can also have local search on that data if you want. Anyone with me? Everyone with me? I like feedback. Okay.
So
Yes, Mike.
my question is, say you're building an application which is not necessarily doing any write offline.
Okay.
So could you just plain old, just have a caching header set with whatever response is sending, and that will be cached, right?
It would be cached, but then caching is another beast of the day. It sounds really simple that things work out of box when they're cached, but when you go to production, you realize things break. You have so much mess when you cache. Sometimes you want updated data, but there might be caching headers being broken on the server side, and you never get those updates. The best solution is to store it offline in a reliable way, which you have a control over, and then request the server saying, give me all the data since this time, because this is the last time I synced the data. Or you can fetch all the data all over again, but sometimes the data might take like 5 seconds to load. And do you really want to make the user wait for 5 seconds? You can show them the offline data first, and when the new data comes in, you can just splice it in.
So even for the first time, whether it be like web SQL or anything, for the first time there's no data in web SQL, right?
Yeah, the first time there is no data, yes.
Right. So it's the same thing with if I use a cache and for the updation on things like that, I can just append it with some registering like timestamp based registering.
It's something similar, but it's slightly far away because you're kind of making your app ready to be offline eventually also this way.
So my real question here is what is the performance that we're looking at here while querying our SQL data and just getting.
You are saving network requests, and that's a huge thing.
That is the same thing with the cache thing, right?
Even if you make a cache, how do you know the data hasn't changed? You'll make a request and the server will say 3 or 4 not modified or something like that. So you're making a HTTP request once, unless you assure the servers that there's no data modified on the server side. So you have to make a request to see if the data is modified or not.
Right.
Why not make a request but keep everything offline also?
Yeah, that's available. Either
Yeah.
Right. I get it.
Okay, so as you mentioned, there are two problems with session storage and local storage. One is that they are synchronization, and one is that it is file-based.
Yeah.
Basically. So can we use web workers for accessing those storage APIs?
Brilliant question, and I thought the same a couple of months ago, and I did it, and then I realized it's a stupid idea because web workers, when you have to do a post message, you have to serialize the objects. You can't pass objects.
Okay.
So when you serialize them, it's unbelievable, but even in the fastest browsers, JSON parse and JSON stringify are extremely slow. So when you serialize it, send it, parse there again, serialize again, and send it back, it's not fast. It's asynchronous though, but then, well, JSON parse and JSON stringify themselves were not asynchronous. If web workers allowed you to pass objects and they could basically clone the objects themselves, there is a structured clone algorithm that's picking up in all the browsers now. So if you store something in IndexedDB, it gets structured cloned. So something similar if was to come in place in web workers, yes, that would be a great idea. But right now it's not. Questions, questions, questions.
Same line as the issue that we don't.
Can you be louder, please?
Yeah, I mean, it's on the same line as the caching question.
Okay.
Yeah, like the caching, I mean, you have to send the request to the server whether it has been modified or not.
Yeah.
So are you suggesting that, for all the static resources that we have on the website, images, CSS, JavaScript, if we use a local storage instead of the caching mechanism of the browser, that would be good.
Well, there are two things. One is not making HTTP requests not so frequently. So if you have local data, you can cool down the amount of requests you're making. That's one. But second is, how many of you use 3G on your phone? And do you feel it's slower than normal computer, normal Wi-Fi internet? There's a reason, because the latency is really huge. Every time you make, the latency is really huge on mobile networks. Every time you make a request on a mobile network, you are literally slowing down the entire UI. Because the lookup, the DNS lookup is really huge. The socket connection time is really huge on mobile networks. There are a lot of mobile websites for iPhone store the images, JavaScript, and CSS in local storage, and then reload it from there for the same reason. Because caching is immensely broken on iPhone. When you say caching works, you're living in a myth. Caching doesn't work. Caching works when you're developing on Chrome. That's it. There are a million other platforms out there, and caching is broken beyond your imagination. So this kind of is it's an auxiliary system that helps you fix where caching is broken, but you can still use caching if you want. There's nothing wrong with that. It's just the whole intent is to reduce the number of HTTP requests and make data available offline. So one day you can say, well, looks like my platform's ready to be completely offline. I just add an app cache manifest and my app is completely offline. I can put it in PhoneGap and it becomes a mobile app. I can also, I forgot to talk about app cache. I think someone pointed out earlier. So it's also something like caching. People think it works out of the box, but it doesn't. So you add an app cache manifest file to your HTML file, saying that this is a manifest file that defines all the resources my page has. And when the browser sees the manifest file, it downloads all the resources in it and then starts working. And when you are offline, it just loads them from the cache and app works out of the box offline. I think it would be completely another session to just pitch about how broken app cache is. So I won't go into details for that. But yeah, once app cache gets fixed, you can, if you're developing like this with WebSQL IndexedDB and local storage, you can build offline applications. You don't need to release an Android app. You don't need to release an iPhone app. Your data is always on the phone. Even if you don't have connectivity, you open the app and it's there. Might be.
So when you use app cache, so the first time it loads in the browser, but when you update that, the first time it loads, but only on the second time you reload your page, it takes from the app cache, right?
Yeah, the first time it freezes the page execution until all the resources in the app cache are downloaded. And once they are downloaded, it continues the rendering of the page. Also, if anything breaks, any resource is missing, it just doesn't render the page at all.
So I'm asking about like when you update something on your app, I mean like some file in the application
On the server side.
And it updates.
It will never get updated no matter how much you change on the server side until you modify the manifest file. Resources will never get downloaded. The browser just caches it and keeps it until the manifest file gets updated. So on every page load, every time you load the page, the browser makes a request to the server saying, is the manifest file updated? If yes, then it re-downloads all the other resources.
So the re-download I'm asking, so the re-download, it happens the first time. I mean like when you update in the server, the user uses it. The first time it loads only the previous version. Only
Yes.
the next time we reload CC.
Yes, so every time if you reload the page, it will see if the manifest file is updated. If it's updated, it will download the resources, and then it will render with the new resources. So that's not an issue. But you can also programmatically trigger a request for checking manifest file update. So if there is an update, you'll get an event saying the manifest file is updated, and then you'll have to say, well, window.navigator.go or whatever. You'll have to manually reload the page.
One question here.
Yeah.
So do the web worker and the UI thread share the same WebSQL instance?
So WebSQL, IndexedDB, local storage, they're all per domain. You can have 5 tabs, you can have multiple windows. As long as they're on the same domain, they'll be shared across.
Okay, so I can write to the web worker and then see the
Yes. So IndexedDB has an alternate synchronous API because a lot of people don't like asynchronous code. It's not done, it's not implemented in any of the browser, it's in the spec. But when that's done, you can have IndexedDB in your WebSQL, in your web worker. So you can have all the database operations in a completely different thread. It doesn't block your UI at all.
And what about WebSQL?
WebSQL is deprecated, the spec is dead. The only reason I mention it because IndexedDB is not available everywhere, and wherever it's not available, WebSQL is available. It's a great fallback. So there's a slightly similar session last year by this guy in Parshuram, and he works a lot on IndexedDB, and yeah, he works a lot on IndexedDB, and he's written a shim that uses WebSQL to emulate IndexedDB. So you just add it to your page, and you can just start writing code for IndexedDB straight away. You can start writing IndexedDB applications today. Just use that shim. Where? Can you? Okay.
What about the lifetime of data for all the
things usually say?
There is no such thing as life, it's permanent storage. So when you save something, it saves.
Like the browser updates like that, if I'm building a Chrome app and I'm storing something in the
It will persist.
if my
It will persist.
app updates or something like that.
It will persist. It will always persist. The idea is it's persistent storage. There is another set of storage called the file system APIs are not persistent. They're temporary storage. So when you store, it will remain stored. You have like I think 32 GB of data available, or the maximum hard drive space available. But if the browser thinks that there's not enough hard drive space available, it can delete. There's no guarantee that data will persist. So it's good to store there, but don't rely on file system APIs.
HTML5 also provides some
Mike.
HTML5 also provides some kind of local storage, right? How is it related to the things?
These are all like IndexedDB and WebSQL are kind of HTML5. WebSQL was the original spec that was started by Google and Google Guest and was adopted in Safari by Apple, and then became a spec in HTML5, but then got deprecated because no one could agree on it.
So how would I know what is the underlying thing that the HTML5 thing is using?
So there is IndexedDB is now the de facto HTML5 storage option. So when you say storage, it's mostly IndexedDB that you're talking about for HTML5. Local storage existed in IE8, and that's a long time ago. It existed in Firefox 3.
Aditya.
Sorry. Yep.
Yeah. So if I'm trying to start building a web application, and the requirement is to be cross-browser supported. Now I've understood what you said, WebSQL, IndexedDB, and what state they are in. But the net, what I want to understand is today if I want to write a very simple app, a user comes in and is put in some of this data, and then once he closes that page and later on he wants to re-log in and then show some of the data that he had entered previously. What is it that I can use reliably which works across all the...
As I mentioned earlier, you could use N-Persurance. I should probably actually share the link online so you guys can see it now. Index. Just look for IndexedDB and we get this page. And you just include the shim in your page, and you have IndexedDB available even when IndexedDB is not available, because it kind of uses WebSQL to emulate an IndexedDB API. You have browsers that don't have WebSQL or IndexedDB, like IE8 or i7. So it all depends on what kind of browsers you want to support. If you're supporting IE8 plus, Firefox 4 plus, Safari 5, and Opera 9, then you just start using this combination and it just works great. There's something similar I have been working on. I can't release it right till the product I'm working on gets released. It's a backbone sync plugin. So if you include that into your page, and every time you say model.save or collection.fetch, it just works through coming from a storage or back into a storage option instead of a RESTful API. So you'll have to write something separately for communicating to a REST API, but the app just works offline. I'll be releasing it in a month. When I do, I'll just put it on Twitter. You guys can follow me. Questions?
Yeah, I have one. When you talk about web storage,
I can't see you. Oh.
Yeah, when you talk about web storage like WebSQL and IndexedDB, so what are the security aspects for that? Like if you're storing some data in cookie, then you have to be very wary, because you can jack the cookie and that's...
You can. So
yeah.
the thing with cookies is cookies stored as plain text file, one. Then secondly, it's transported over network. None of that's happening for IndexedDB or WebSQL. IndexedDB is encrypted and stored. WebSQL is SQLite. So if you have access to the file system, you can say SQLite my file name and you can access the DB. But that's quite improbable that people will have access to your file system. It's a lot less improbable compared to cookies being sent over network.
But let's say the system on which you store the data, if somebody gets access to that remotely or somehow. So what I'm talking about is what kind of data you can store for the user's session
in the website, in the browser storage, whether you have to be as wary as when you use the cookies, or you can, let down your guard a little?
A little bit less than cookies. Cookies are extremely insecure. Yeah. It's still insecure, but not as much. I would suggest if something is really important to you, like really secure data, just use some kind of encryption mechanism and just put the encrypted data in and just download the key every time from the server side.
Thank you very much.